Hello, hi friends, welcome to my channel. Today in this video we are going to learn about applications of trigonometry. In applications of trigonometry, already in the previous video we learned about angle of elevation, angle of depression, and I think you got those concepts. Now today, using those concepts, let us see how to solve the problems. So let us see some examples how to solve the problems based on applications of trigonometry. Let us take one example. The top of a tower is at an angle of elevation alpha degrees and the foot of the tower is at the distance of d meters from the observer. Draw the diagram for this data. If you observe the data, the observer is observing the top of the tower with an angle of elevation alpha degrees and the observer is standing at d meter distance away from the foot of the tower. This is the given data. Using this information, we need to draw the rough diagram for this situation. Let us see. So for this, first we need to take a tower. So let us take a tower and represent the height of this tower with a straight line and name the straight line as AB. Now this ground will be treated as horizontal line, and on this ground at a point take the position of the observer, and this position represent with the point C, and this point C, the observer is observing the top of the tower, that is B. So let us join the observer's eye and the observing point, which is B. Now this line is known as line of sight. So the line of sight is the line segment that joins the observer's eye and the observing point. Now here, if you see, between the line of sight and horizontal line, an angle is formed. This angle is known as angle of elevation. And in this problem, this angle of elevation is given as alpha degrees. So let us represent this angle as alpha degrees. Now the distance between foot of the tower. To the observer is given as d meters. So write the d meters here. Now remove the pictures from the diagram. Now we get the right triangle ABC, where angle C is alpha degrees and the length of AC is d meters. So this is the suitable diagram for the given situation. Let us see one more problem. Rinky observes a flower on the ground from the balcony of the first floor of a building at an angle of depression beta degrees. The height of the first floor of the building is x meters. Draw the diagram for this data. So in this problem, if we observe the given data, the girl Rinky, who is standing on the first floor of the building, and from there she is observing the flower which is on the ground with an angle of depression beta degrees, and the height of the first floor is also given as x meters. Now using this information, we need to draw the rough diagram for that situation. Let us see how. So let us take the building and also take the girl Rinky, who is standing on the first floor of the building. Now let us represent the height of the first floor of the building with a line segment AB, and its height is given as x meters. Now on the ground, take the position of the flower at a certain point, and name it as C. Now Rinky is observing the flower C with an angle of depression beta degrees. So let us join the observer's eye to observing point. So this is known as line of sight. Now here we have the line of sight, and from the observer we need to draw one more line segment, that is horizontal line. So let us take the horizontal line from observer's eye. So now this is the horizontal line and this is the line of sight, and between these two an angle is formed. This is angle of depression, and which is given as beta degrees in this situation. Now we know this is the horizontal line to the ground, that means both are parallel lines, and this line of sight is the transversal. Now these two angles are alternate interior angles, so this angle also become beta degrees. Now let us remove the pictures from this diagram. Now we got the right triangle ABC At vertex C we have the angle of at vertex we have the angles beta degrees and the length of the building, that is x meters. So now we got the diagram for the given situation. This is the way of representing the situation in diagrammatic form. Now let us take one more problem. Example 3. A large balloon has been tied with a rope and it is floating in the air. A person has observed the balloon from the top of a building at an angle of elevation theta 1 and foot of the rope at an angle of depression theta 2. The height of the building is h feet. Draw the diagram for this data. So here in this example, if you observe, a large balloon has been tied with a rope and it is floating in the air. And a person who is standing on the top of a building, and from there he is observing the large top of the balloon and also is observing the foot of the rope. This situation. Now the height of the building, that is h feet, is also given here. Now using this data, we need to draw the diagram for this situation. Let us see. So here, first the observer is standing on the top of a building. So let us take a building. On the top of the building, an observer stand there. And let us take the ground with a straight line. And the height of the building represent with a vertical line and name it as AB. And now take a large balloon which has been tied with a rope and name its bottom position with C and the top point of the balloon with D. From the observer's eye, we need to take the horizontal line. Let us draw the horizontal line from the observer's eye. So let us assume this line as BE. Now the observer is observing the top of the balloon with an angle of elevation theta 1 and the observer is observing the foot of the rope with an angle of depression theta 2. So let us draw the line of sights. And now the observer is observing the top of the balloon. So let us join the observing point and the observer eye with a line segment. This line segment is known as line of sight. And here between horizontal line and line of sight, an angle is formed. So it is angle of elevation. So it is given as theta 1. Now again the observer is observing the foot of the rope. So let us take the line of sight from observer's eye to the foot of the rope. And again here between horizontal line and line of sight, one angle is formed. Now this angle is known as angle of depression and it is given as theta 2. And we know that this is the horizontal line and this is the ground, both are parallel to each other, and this line of sight acts as transversal. Therefore this angle of depression theta 2 will become equal to the angle BCA. So we can take angle BCA as theta 2 since they are alternate interior angles. Now let us remove the pictures from this diagram. Now we get the diagram for the given situation. So this is the given diagram, rough diagram for the given situation. And here also we have the height of the building, that is h feet. Let us take one more problem which is given in our textbook. From do this, a person is flying a kite at an angle of elevation alpha and length of the thread from his hand to kite is L meters. Draw the diagram for this situation. In this problem, a person is flying a kite with an angle of elevation alpha and the length of the thread is also given as L meters. So now we need to draw the diagram for this situation. So let us see. So let us take the kite which is flying in the air and we have the thread which is representing with white line and the length of the rope from the person hand to the kite is L meters given and he is flying the kite with an angle of elevation alpha. Let us represent the height of the kite from the ground with a straight line, that is AB. Now AB is represent the height of the kite from the ground. Now on the ground at a certain position observer is there Let us assume the observer's position on the ground at a certain position, that is C, and from point C the observer is flying the kite, and if we join the point C and the kite, the point B, we get the line of sight. Here the thread will become the line of the sight. Now here between the ground and the thread an angle is formed, that is known as angle of elevation, and which is given as alpha here. So let us write the alpha. Let us represent alpha angle here. So let us remove the pictures from this. The length of the thread is given as L meters. So label the L meters here. So label L meters here. Now we got the right triangle ABC with an angle of elevation alpha degrees, and the length of the thread is L meters. Now we get the right angle triangle, which is the suitable diagram for the given situation. And let us see one more. A person observes two banks of a river at an angle of depressions theta 1 and theta 2, where theta 1 is greater than theta 2, from the top of a tree of height h meters, which is at the side of river. The width of the river is d meters. Draw the diagram to this given dot. So in this problem, a person is observing the two banks of a river from the top of it, and the tree is at a side of it, and the tree is at one side of the river, and he is observing the two banks with angles of depression theta 1 and theta 2, and the height of the tree is h meters is given, and the width of the river is d meters also given. And using this information, we need to draw the rough diagram for the given situation. Let us see. So let us take a river, and on the river on one side, let us take one tree, and on the top of the tree an observer is there. From there he is observing the two banks of the river. Let us represent the height of the tree with a straight line. Assume it as AB, and which is given h feet. The height of the tree is given as h feet. So first we need to draw the horizontal line from the observer's eye. So let us take the horizontal line from the observer's eye, and then the observer is observing the two banks of the river. So let's suppose first he is observing the first bank of the river, and from the top of the tree the observer is observing two banks of the river. Now let's suppose the observer is observing the first bank of the river. So we need to draw the line segment from the observer's eye to the point which he is viewing. Now from the observer's eye, we need to take the line segment to the point which he is viewing. Let us assume the bank of the first river with a point C. And he is viewing the point C from the top of the tree, from the point B, which is at the top of the tree. So let us join the point B and point C, so we get line segment BC. So now here between horizontal line and the line segment we get an angle. Here the line segment is below the horizontal line, so then the angle found between these two we call it as angle of depression, and the angle is given as theta 1 degrees. Theta 1. Now again, from the point B, the observer is observing second bank. So let us assume the second bank of the river with point D. Now let us join the observer's eye, that is point B, with the second bank, with the point that is second bank of the river. Now we get one more line segment BD, and here again with the horizontal line, the line segment, second line segment BD is making an angle, is making some angle which is given as theta 2. So let us represent this angle with theta 2. So this is the angle of depression. Now let us draw the diagram for this. So let us take on the ground a river is there, and the two banks of the river we are representing with point C and D. So represent the height of the tree with AB, and it is given as h meters. And from point B, the observer is observing the first river bank point, that is C. So let us join BC, and next between the horizontal line and line of sight there is an angle formed, that is angle of depression theta 1, which is given theta 1. And again the observer is observing the second point D, and join these two. Again we get an angle between horizontal line and line of sight. So that is given as theta 2. And here the width of the river is also given, that is. So this is the suitable diagram for the given data. Now let us see one more. Example 4, which is given in the textbook. A boy observed the top of an electric pole at an angle of elevation 60 degrees. When the observation point is 8 meters away from the foot of the pole, find the height of the pole. So in this example, a boy is observing the top of an electric pole with an angle of elevation 60 degrees. And the distance between the boy and the foot of the tower is 8 meters given. So now this is the given information, and using this information we need to draw the suitable diagram for this situation. Let us see how. So let us take first an electric pole. Let us take first an electric pole and represent the height of the electric pole with a straight line AB, and on the ground at a distance of 8 meters away from the pole, the observer position is there. Let us assume this position as C. And from this position, the observer is observing the top of the electric pole with an angle of elevation 60 degrees. So now we need to join this point C and point B. By joining these two, we get line of sight. And here between line of sight and the ground, we got an angle, that is an angle of elevation, which is given as 60 degrees. So let us write the 60 degrees angle here. In this way we got right triangle here. Let us remove the pictures from this diagram. So after removing the pictures, we get the diagram for the given situation. Here in right triangle ABC, at vertex C, the angle of elevation is 60 degrees and the length of AC is 8 meters is given. So this is the suitable diagram for the given data. And let us see how to find the height of the pole. From the figure in this triangle ABC, we have the length of CA, that is 8 meters, and the angle of elevation, that is angle ACB, is 60 degrees. We need to find the height of the pole, that is AB. So let us assume its height as h meters. So if we observe this right triangle ABC, we have the length of AC, that is 8 meters, and we have one angle at vertex C, that is 60 degrees. And using these two informations, we need to find the height of the pole. So how? Let us see. Here for the given angle 60 degrees, for the given angle ACB 60 degrees, the given side AC is the adjacent side. And the required side, that is AB, which we need to find, that is the opposite side for the given angle 60 degrees. So here we have the adjacent side for the given angle, and we need to find the opposite side. So to the opposite side and adjacent side, if we consider that ratio, and we know that the ratio between opposite side and adjacent side is tan. So here we need to consider the tan ratio to find the height of this pole. So let us see. So we know the adjacent side and we need to find the opposite side of angle ACB in this right triangle ACB. Hence we need to consider the trigonometric ratio tan to solve this problem. So if we take tan 60 degrees is equals to AB, which is the opposite side, and the adjacent side is AC. So tan 60 degrees is equal to AB by AC. Then if we substitute the corresponding values, we get root 3 equals to h by 8, where AB height we assume as h meters and the distance of length of AC is 8 meters is given. And transposing 8 to left hand side, we get h is equal to 8 into root 3 meters, which is the height of the pole. Hence we get the height of the pole 8 into root 3 meters. And see one more problem, example 5. Rajendra observes a person standing on the ground from a helicopter at an angle of depression 45 degrees. So Rajendra is a person who is flying in the helicopter. From the helicopter he is observing the person who stands on the ground with an angle of depression 45 degrees. If the helicopter flies at a height of 500 meters from the ground, what is the distance of the person from Rajendra? So it is also given that the helicopter is flying at a height of 500 meters from the ground. And what he is asking, what is the distance of the person from Rajendra? So we need to find the distance of the person from Rajendra. So to solve this problem, first we need to draw the diagram, suitable diagram for this given situation. Let us see. So let us take a helicopter. Imagine a helicopter, and from the helicopter, in the helicopter, the Rajendra is there, and the height of the helicopter from the ground is given as 500 meters. Let us take this height of the helicopter from the ground with the lines, with a straight line AB, and which is 500 meters is given. And on the ground, take the position of the person as C. And from helicopter, the Rajendra is observing the person. So join Rajendra to that person, which is, that line segment is known as line of sight. So from observer I, we need to draw the line of sight to the observing point. So that is BC is the line of sight. And again we know we need to draw one more line from the observer I, that is horizontal line. So draw the horizontal line, that is BD. Now here between the horizontal line and line of sight an angle is made. This angle is known as angle of depression, which is 45 degrees is given in this problem. This is the angle of, so let us write the angle of depression 45 degrees here, and this is the angle of depression 45 degrees. Now let us remove the pictures from this diagram and we get the diagram for the given situation. So here we got the triangle ABC, right triangle ABC, and the angle CBD, which is outside the right triangle, that is 45 degrees, and we can shift this angle to vertex C since these two angles are alternate interior angles, so they are equal. So let us see the solution. So from the figure, in right triangle ABC, we have the height of the helicopter, that is AB equals to 500 meters, and we know the angle DBC and angle BCA are alternate interior angles, hence they are equal. So we can write angle DBC and angle BCA both are equal 45 degrees. And then we need to find the distance between the Rajendra and the person. So let us assume this distance with x meters. Now we need to find this length x meters. And if we observe this figure, for the given angle 45 degrees, we have the opposite side, that is AB, which is given 500 meters. And we need to find the length of hypotenuse, which is x meters we observe. So for the given 45 degrees angle, we have the opposite side and we need to find the hypotenuse. So here we need to take the ratio between opposite side and hypotenuse, hence we consider sine trigonometric ratio. So let us take sine trigonometric ratio for the angle 45 degrees. So sine 45 degrees can be written as AB by CB, where AB is the opposite side to 45 degrees and CB is the hypotenuse. And substituting the corresponding values, we get 1 by root 2 equals to 500 by x, and on simplifying this we get x equals to 500 into root 2 meters. Therefore x is the length of the x is the distance between the person to Rajendra. So therefore the distance between the person and Rajendra is 500 root 2 meters.